So electromagnetic induction, what it states that whenever there is a change in magnetic field, there is always a current. And how we can change the magnetic field is either by moving the magnet or the wire in the magnetic field. And whenever we want to find the direction of a current, so what we do, we use right hand rule. If we want the direction of a current due to change in magnetic field, so to find the direction of a current produced due to change in the magnetic field, we use right hand rule. So if I ask which direction the current produced here, example, if this arrow was not given and you want to find the direction of a current. So first finger, your first finger and index finger pointing towards the magnetic south, magnetic field or south pole. So your right hand index finger should point on towards the right hand side. So your index finger of right hand should point towards the right hand side because south is on the right hand side. Then your thumb, because we know the motion of the wire, so your thumb represents the motion of the wire, the movement of the wire. So where the wire we are moving the wire downward, as you can see in the figure. So your thumb, right hand thumb should point downward. So your index finger should point towards right, and your right hand side, thumb should point downward. As a result, when you find, you'll find this where your second finger is representing. Your second finger will represent the direction of a current. So when you apply the rule, your index finger is pointing towards the right hand side, the first finger or index finger, and your thumb is pointing downwards. You will find that the second finger will point outwards or out of the screen, or in this manner the current will produce. So whenever we want a direction of a current produced due to change in magnetic field, we always use the right hand rule. And this is known as the Faraday's law, that whenever there is a change in magnetic field, there is always a current. And the direction of a current changes with the direction of a motion of a wire or change in magnetic poles. As you can see in this figure, the first figure, we are moving downward. So the current was outward, like coming out. But the other figure, we are moving the wire upward, so the current is pointing inward. So the direction of the current changes as we change the direction of motion of wire. And the amount of a current or strength of a current depends on how fast we are moving, how many turns are there, and what is the strength of a magnetic field. So this is a right hand rule which we use to find the direction of current produced due to change in magnetic field. So induced current can be increased by moving the wire faster, using a stronger magnet, or increasing the number of turns. Then there's a Lenz's law. Lenz's law means it states that whenever the current produced, it will always try to oppose the change. So example, we have a circular wire and initially there are no poles. The magnet initially, example, not moving. But what happened? Now we are moving the magnet towards. So as a result, when we are moving the magnet towards, there is a change in the magnetic field, and the magnetic field start to increase because we are moving the magnet towards. So according to Lenz's law, the current will produce due to change in magnetic field always try to oppose the change. So how it can oppose the change? As we are moving a north pole towards the solenoid and the strength of a magnetic field is increasing. So what pole will be induced? It will produce a north pole on the left hand side and south pole on the right hand side. So it can oppose the magnet. And opposite will happen. Opposite will happen if we are moving the magnet away, the strength of a magnetic field is decreasing. So if the strength of a magnetic field is decreasing, what the solenoid or a wire will try to do? It will try to oppose the change. So how it can oppose the change? By producing an opposite pole. So if north pole is moving away, so what pole will be induced here? So this will be south because the strength of a magnetic field is decreasing. So what this solenoid will try to do, it will try to oppose. How it can oppose? By attracting the magnet. And how it can attract the magnet? By producing a south pole on the left hand side and north pole on the right hand side. So the direction of the poles produced on the solenoid changes. That's why the direction of the current or the deflection will also change. So if you are moving the magnet towards, like in the previous example, we were moving the magnet towards, so the needle example deflected towards the right hand side. And opposite will happen if you are moving the magnet away, the needle will deflect in opposite direction. And the amount of deflection depends on at what speed we are moving the magnet. If we are moving the magnet at a higher speed, either towards or away, the deflection will be large. The AC generator, an AC generator is used to produce electricity by using the concept that change in a magnetic field produce current. So what the AC generator consists of? It consists of a rectangular wire which is supported on the axle between the magnetic poles, and these are called slip rings. So how to identify whether it is an AC generator or DC motor? If it's an AC generator, it will always have a slip ring. Slip ring means that complete circles are there. And in DC motor, there is another type of a ring which is called a split ring. Like rings are split. So this is split ring. What is the purpose of the slip ring? Slip rings are used to take out energy from the rectangular coil or a solenoid. So as a result, what happened? When the coil is moving, as you can see, it is rotating. So due to rotation of a rectangular wire, there is a change in the magnetic field. And due to change in magnetic field, there is always a current. When the current is maximum, you can see in the figure, in this animation, that the current is maximum when the coil is horizontal. So when it is horizontal, maximum, and when it is vertical, it is minimum. And it continuously changes the direction. So the output of the AC generator is always a cycle. So it shows this position where the voltage is 0, coil is vertical. Where the voltage is maximum, horizontal. Then again vertical, 0. Horizontal, maximum. Vertical, 0. This is one cycle, like one complete rotation. And why the direction of the current is changing continuously? So why the direction of the current is changing continuously? Because the sides are changing. Like example, if I label this side as A and this side as B. So when it rotates, it turns around. So A changes the position with B and B take the position of A. So the direction of A and B changes with reference to the poles. That's why the direction of a current is also changing. Like first A was moving near south, now it is moving toward, or A was moving near north, now it is moving towards south. And B was near south, now it is moving towards north. That's why the direction of the current changes. So rotation of a wire produce a change in the magnetic field, and change in magnetic field produce current. And the strength of the current varies, depends on the position of the coil. If it is horizontal, it will be maximum. If it is vertical, it is minimum. So in a one cycle, you have to complete one maximum positive side and one maximum negative side. This is a one cycle or one complete rotation. And same thing, the second cycle, one maximum positive, one maximum negative axis. Like we have to use both axes so that it shows that the current is continuously changing. And a DC motor, if you want to find force on the wire which is carrying the current, so we use Fleming's left hand rule. Our first finger, index finger, point towards south. Our second finger represents the direction of a current, and thumb will point in the direction of force. So DC motor, The main difference between AC generator and DC motor, AC generator convert the kinetic energy to electrical energy. Like we rotate, it produce current. But in DC motor, we pass the current and start to rotate. So in a DC motor, like here you can see the figure for a DC motor. These are the split rings. How you identify a split ring? Like the rings are not connected with each other. There's a space between them. So this is called a split ring. So DC motor uses a split ring, where an AC generator uses the slip rings. Now what happened? The electrical current, the conventional current moved from positive. So this is the direction of the current. So when we apply the Fleming's left hand rule, you have to use the left hand rule. So index finger, if I want to find force on AB, so index finger is pointing towards the south. So index finger or first finger is pointing towards the right hand side. Second finger represents the direction of the current, which is into. So where the thumb is pointing, that is the force. So you'll find your thumb will point downward. So force is downward. So as a result, when this side force is downward, other side force is upward. So this coil will start to rotate. So on the left hand side, we have X, and on the right hand side, we have Y. But as the coil flip, as it rotates, the position of X and Y also changes. So first X is on the right hand side, Y is on the left hand side, and AB on the right and CD on the left. But as it flips, now what will happen? This will be Y, this will be X, and this is CD, and this will be A and B. So what is the purpose of the split ring and commutators? The direction of the current is now changed. How the direction of the current changed? Even though it looks like same, but it has changed. Why? Because the current is moving in this manner. Now the current is moving from D to C, then C to B, and then B to A, and then return back. So the direction of the current has reversed. First, the direction of the current was from A to B, and now it is from B to A. So as a result, the direction of the force will also change, and it will keep the wire rotating in one direction. So you have to learn the purpose of the split rings commutators. So the purpose of the split ring commutator is to reverse the direction after every half rotation, so that the coil will rotate in a fixed direction or one direction. And we can increase the strength of the current. We can increase the strength of rotation of this coil by increasing a current, or by increasing a number of turns, the strength of a magnetic field, as well as area of the coil. And these are the rules in magnetism. This is important part. How you will know which rule to use. The first one is the right hand grip rule. Right hand grip rule, it is valid to find the direction of a magnetic field due to a current for straight and a circular wire solenoid. So if we have a straight wire or we have a circular wire, so we'll use this right hand rule to find the direction of magnetic field. Right hand grip rule. The second one is a Fleming's right hand rule. It is used to find the direction of a current produced due to change in the magnetic field. When the magnetic field is changing, there will be a current produced, and this current produced can be identified by using a right hand grip rule. Right hand rule, Fleming's right hand rule. Grip rule is for magnetic field, finding the magnetic field due to a current, and Fleming's right hand rule is used to find the direction of a current due to change in magnetic field. Whereas Fleming's left hand rule is used to find the direction of the force on a wire which is placed in a magnetic field. So three rules of a magnetism. One is right hand grip rule to find the direction of a magnetic field due to current. The second one is the direction of a current produced due to change in magnetic field. And the third one to find the direction of a force on a wire which is placed in the magnetic field.